Hello everyone, my name is Xuchen and welcome to my project. My project have three steps. First one is use GAN to generate pictures. Second one is use CN to add feathers to this image, and then use these pictures in game development. I also implement some functions of the paper and I put it in this folder. And I also included some necessary development software in this folder. It's very important. So first, I introduce some important necessary components of my project. First is build the development environment. So it's very important for us to use PyCharm. Also, it has some limitations. For examples, if your CPU is not so very powerful and if you don't have any GPU, so in this case, it's better for you to use Google Colab Online servers, so it will be better. But I upgrade the hardwares of my computer and I use NVIDIA GPU 1080 Ti and GPU to accelerate my the training of of this algorithm. And I also use AMD 3900 and CPU. So in this case, I should use a PyCharm, and it will be quick than the web servers. And the next step is that when you download these three steps, step 1 and step 2, and use the PyCharm to open them. And when you use the PyCharm, it's necessary to set up the Python interpreter. So I install the Python 3.9 and the default Python interpreter in PyCharm, and I can set the version of Python which can be used in PyCharm. So I select 3.6. So it's generally uses for data learning, for machine learning. So this is very important thing. Another thing is that install the necessary package. For example, let me show you. And for example, you include this is, as you can see, this is a GAN folder, and you include the GAN folder. For example, it should have some problem in here. It says that they will get some errors in here. It says that missing the model of TensorFlow. In this case, you should install the packages into your computer. And after the installations, the model of Python will be installed in the library of Python. As you can see in here, I always use Python for machine learning, so my library is really huge. It's 2.65 gigabits, so yeah, it's bigger than usual. And next thing is install CODN tools. So if your computer don't have any GPU, so please don't it's not necessary to use that. If you have a GPU, and it can be accelerated for the for the programming. So in this case, it's necessary to download the CODA tools and the CODN. CODA and CODN is different. So first is when you install it, the CODA tools and the CODN, it's necessary to make it matched. Matched means that in the CODA website, they will have the version of the CODA, and they will they will use, for example, I use the version 11.2, and for the CODA, they will have a suitable version for CODNN, so they will have details in the website. When you installation, you have to notice for that. And after the installation, you can use cmd command to test if the CODA and CODN can work. For example, is NVCC point version -version to test if the CODA can work. And another is that use CU Davis Coin in the demo of the extras field in CODA to test if CODA can work. So if CODA and CODN work, the output will be your GPU informations. For example, in here I use GTX 1080 Ti, so it will show in here and show the bandwidth of GPU. And very important thing is that another very important thing is that when the executing of the TensorFlow or PyTorch, they will show some missing if you don't have any deals. So, but no worry, I put some necessary deals in the development environment build folder, so if you're missing something, you can copy it and move it into your library in bin folder. It must, if it's missing something, you must put the missing DLL file into the bin folder of CODA tools. And then let me show how it works. This is my algorithm of GAN. First, select the GAN2 file and run for that. And then you can see that the output will include every necessary CODA DL files. So as you can see in here, if there is any one DL files is missing, the program will stop. So it's very important to set that. And first, to set the SLA self-service is very important. So I use this environment. I import the OS package and use this command to set the SLA devices. As you can see, I print the layers and informations of generator is in here. Totally, it uses 16 million parameters, so it's very huge. And I try it on web cloud servers, and the training is really slow. But when I try in my local equipment, it will be very quick. And this is the discriminator details, and totally is 2 million parameters. And this is the training. So as you can see, almost half a minute or 33 or 40 minutes per one approach. And I use this, and I use let me see. And I use this approach. That means every 2 approach, I use this command to save the figure into current here. And when it's finished 200 approach, and it will print training is finished. So training really need a lot of time. I don't, so I just stop it. And when you finish the training, please stop sign, and the result of approach will be in here. As you can see in here, the first generator approach is not good, and the last one will be better in here. So it's necessary for me to select one proper approach result and then use it in the GAN network. Second, I introduce the GAN network, and as you can see in here, select the GAN2 and select run GAN2. So for first one, GAN, I use TensorFlow package. For the second one, I use the PyTorch. And for PyTorch, they will not have the informations of the CODN or CODN. And this is because my GAN network is very smaller. It only use 5 layers. So not that 20 layers, almost 20 layers or 25 layers. In GAN, it's only 5 layers, and the layers is pre-trained. So this is the output of the training. As you can see, the training is really fast. With the training, the total loss value is reducing. So for the iteration part, I select the smaller the images which the loss value is smaller, and then at the end the image will close to the contact image in content value, and near the still image in still value. So that's it. As I show some result, training is need a lot of time. And for example, this is the first content image, and this is a still image, and this is a final image. So as you can see, this is a final image, and the content 2, content 3. And I saved the loss values in the type of HTML. So yeah, then you can see it in the iteration 1. So the contact will 0, and with the training, the contact loss value will reduce. And this is a still loss image. At first, the still loss image is very huge, and at the end, the still image, the loss value of still image is reduced. So the last picture will have the phasors from still image, and the contact will be near to the contact image. And the second thing is that I implement some functions of GAN in paper, GAN with OPC, and I can show you. In fact, I still have some problem in the I defined 2 different discriminators and two different generators. For the generators, in fact, I implement the functions, but it needs some changes. The paper use PyTorch. The paper use VJJ13 as the discriminator, and use U-type generators. And I also implement the functions of unite generators. But for the discriminator, I defined the VJJ discriminator with VJJ3, but it still has some problems. So I use the discriminator with pitch type, and I can show the training for that. then run the training. So the is here, and the training is 1 by 1. The maximum of epoch is 200. So yes, and I can show some results. This is some results of my previous training. And first, you can see in here the max without OPC is here, the max with OPC is here. The GAN predict is not clear, and after training, for example, in here, the GAN predict is very close to the max with OPC. So the more training, the GAN will be more better. Yeah, and the second and the last thing is that I show you how to use the UE4 Unreal packages and compile and packages Unreal Engine in here, and I package for the Windows platform. So it's an executable applications in Windows. So just click it.
Hello everyone, my name is Yuchen. Welcome to my project.
And in here,
To control the character, please press WASD. To control the light in the front of character, please press E. And if you want to use the web browser in-game, please stand in the front of web browser and press R. And if you want to quit the web browser, please click the button on the right of the screen. Click X to close the web browser and return to the environment. Thanks for using. Have a good day.
I show you how to use the web browser for online monitoring, for the monitoring the And the next step is mount to the drive. OS command is to show the fields, so all the folders in this case. The second is mount to go driver. And press this one to get the operations. mounted. When the mounted, it will show the containers of driver. So I have already uploaded the GAN and the same networks in here. So next thing is that to run the Python and fields to show that. First, we run the GAN models. This command means move the parent to the step 1 GAN, and ls that means show all the fields in here. And second is that run the GAN to Python field, as you can see in here. This will output all the informations of the Python. And the first thing is loading the informations and loading the data. So, but it will have some buffer overflow probably, but it will very slow because the web server's CPU is not very good, so we don't do that. And we stop it. And we can run the same model. Same model is much smaller and can run perfectly in here. So let's see that. First, it has to download the VGG19 pre-trained network, and then it will build the information to use PyTouch. So we just wait. And then you can see that for the every training, the loss functions, loss value will be smaller and smaller. And then they will show the final image. This is the result of previous training, as you can see here. We will load the image here. Yeah. So this is how to use the in-game web servers to monitor the training of GAN and CNN model. Press X to exit. And then I will show you the results of the image. As you can see here, the building, I built the passive elements of uniform object and combine them together in the uniform sense, as you can see here. This is the final sense. For the range out, it's an immutation. And then I simulate the range out and declare and destroy it when it clicks the downfold. In fact, it's a cubic, so generate it from the top and destroy it in the floor, so make it more real. And this is our signal. So we have some light reflections of the channel light. So when I turn off it, it will show more blue. And next step, I show you some more images. As you can see, it is more real, right? In here, as you can see, this is another light, another pictures. As you can see here, this is the pictures of our engineer faculty in the first floor. I take the pictures in front of the class, and then use cement and some filters, so it will look more good. And this is my pictures. So that's all. And then press the dash in the command line and exit to quit the program. So that's all. Thank you for watching.